the third session on chi-square test. In this session, we will deal with the chi-square test of homogeneity. Like the name suggests, this test is used to test whether two samples have the same characteristic. So, this test is applied to a single categorical variable from two or more different populations. Say for example, you are going to study the investment behavior of people in two districts. So the categorical variable is the investment behavior, and you have different populations, that is the population that you have taken from the two different districts. So when you test whether the investment habits or investment behavior of these two districts is homogeneous or not, then you use the test of homogeneity, and it is used to determine whether frequency counts are distributed identically across different populations. For example, in a survey of TV viewing preferences, we might ask respondents to identify their favorite program. We might ask the same question of two different populations such as male and female. We will use a chi-square test for homogeneity to determine whether male viewing preferences differs significantly from female viewing preferences. So there will be more than one sample in this test, unlike the test of independence where there will be only one sample and you will be testing the independence of attributes, two or more attributes in a particular sample. But in test of homogeneity, you will be having more than one sample and you will be testing the homogeneity with regard to a particular characteristic. It tests whether two or more samples are homogeneous as far as a particular attribute is concerned. When there is homogeneity, we conclude that the same samples are drawn from the same population. The procedure is same as that of test of independence, and the null hypothesis will be there is homogeneity among the samples or there is no significant variation among the two populations or two samples, whatever it is. So we are not listing out the steps or procedures involved in testing the homogeneity, because it is same as that of the test of independence. So for first one, we have to set the null hypothesis and then we have to apply the test statistic. There is no difference in formula. The test statistic chi-square, you will calculate chi-square by with the formula O minus E square by E, sigma O minus E square by E. And to find out the expected frequencies also, you can use the same formula, row total into column total by grand total. And then degrees of freedom also, there is no change. The degrees of freedom is R minus 1 into C minus 1. And depending upon the level of significance and table value, you will be accepting or rejecting the null hypothesis. Let's look at an example. From the adult population of 4 large cities, random samples were selected and the number of married and unmarried men were recorded. So 4 large cities constitute 4 different samples, and marital status is the categorical variable that you are going to check whether there is homogeneity in that particular categorical variable. So the data is like this. There are 4 cities A, B, C, D, and you are classifying the people on the basis of the marital status. Then the question is there significant variation among the cities in the tendency of men to marry? So while going for the solution, your first step is of course to set up the null hypothesis. The cities are homogeneous or there is no variation among cities in the tendency of men to marry. You can either put it as the cities are homogeneous, or you can well explain what it is. Then you are listing the observed frequencies. This is what is given in the question itself. The only thing is you are vertically writing the observed frequencies. Then for each cell frequency in the question, in the table it is given, you will have to calculate the expected frequencies, and you will get the expected frequencies as 130, 39, 170, etc. When you calculate the expected frequency with the formula row total into column total divided by grand total. Then again you have to find out O minus E square and then O minus E square by E. Then your chi-square, you can derive with the chi-square value. It is a sum of the last column, that is 5.9. Then the next step, of course, is to find the degrees of freedom. Here, the number of columns and rows differ. It's not a contingency table as in the case of test of independence. So the number of rows and columns will be changing depending upon the number of samples that you have. So the degrees of freedom is 2 minus 1 into 4 minus 1, that is 3. And the table value at 3 degrees of freedom at 5% level of significance is 7.82. Now you have to compare your calculated value of chi-square 5.9 and the table value 7.89. And you find that the calculated value is less than the table value. Then what you have to do? If the calculated value is less than the table value, you have to accept the null hypothesis. So that is all about testing the homogeneity, chi-square test of homogeneity. So what I asked to the students is that you should do more problems related with goodness of fit, related with independent test of independence of attribute and test of homogeneity. It's a very simple part from in your syllabus for which you can score marks. The only thing was you have to identify the question that it is from chi-square. When you study ANOVA and all the questions will seem to have the same characteristics, mean same nature. So understand that if one sample is given and you are given two attributes and you are the sample is classified on the basis of two attributes, then it is possible that it is the test of independence of attribute. And if more than one sample is given and it is classified on the basis of one particular categorical variable, then that may be then you can apply the test of homogeneity. So the only thing in chi-square is that you should be able to identify. You should be able to identify whether it belongs to chi-square or not. No other problems. There is no much formulas, so it will be easy for you. So if you have any doubts, please clarify.